Alright, here's part 1. Still, we're just clearing fractions. Part 2 of 8.4 will be clearing decimals. But this is take 2 on part 1 for clearing fractions. So the big thing to remember here is that when you are dealing with fractions, you want to determine the LCD first. Once you have your LCD, your least common denominator, you can clear the fractions by applying the distributive property to both sides with your LCD and canceling it out. Once the fractions are canceled out, then it just becomes a basic 1 or 2 or multi-step equation where you would find out what's happening to your variable, apply reverse PEMDAS, and apply the inverse operations to isolate one positive variable. Not difficult, just takes some practice, so hopefully rewording it another way can help you understand that. So in this first example here, we are going to determine our LCD, first step. So the LCD of 3 and 6 is 6. So you're going to multiply both sides by 6, or 6 over 1. We're multiplying it by 6 over to 1 to keep the 6 upstairs in the numerator, so it'll be easier to cancel out. So we multiply both sides by 6 over 1, and then you distribute into however many terms there are. In this case, there's 2 on the left and 1 on the right. This is the important step here when you're distributing, so that way you can see it applied to each term in the equation. After you've distributed, then you want to go about canceling out and simplifying. So how many times does 3 go into 3? Once. 3 goes into 6 twice. 6 goes into 6 once. 6 goes into 6 once. 3 goes into 3 once. 3 goes into 6 twice. So after you do that, then you want to simplify it and bring it down. This is also an important step here because you don't want to forget any of those little numbers here that you went about simplifying. So once you do that, then you just rewrite everything. So 2 times x plus 1 equals 2 times 2. Notice I parenthesized everything. That's helpful to keep your negatives where they go and making sure you have all of the terms that you need. Alright, after we have that, we're simplifying it down, and we have our 2x plus 1 equals 4. So in this case, you want to determine, yes, what's happening to the variable? Okay, so you want to determine what's happening to the variable over here, and you want to apply reverse PEMDAS in order to isolate what? Yes, one positive variable. So first, x is being multiplied by 2, and it's being increased by 1. So with reverse distribution, you want to get rid of the plus 1 before you get rid of the multiplied by 2. So applying our inverse operation, what's the opposite of adding 1 to both sides? That's right, subtracting 1 from both sides. So what you do to one side, you must do to the other. That is the law of equality. So 4 minus 1 is 3, bring down your 2x. So now what's happening to the variable? 2 is being multiplied. What is the inverse of multiplying by 2? Dividing by 2. And so then you have 3 halves, or x equals 1 and 1/2. When we're playing with fractions and decimals, after you find your final answer, I want you to check it with the calculator just to make sure that it's correct. Once that's good to go and making sure you did all your math right, you are good to move on to the next example. Example number 2 deals with the another problem, but we have multiple x's all around the equation, and we also have different denominators. So we have a 3, a 2, and a 6. So again, first step, find your LCD, and your LCD in this example is 6. Once you have that, just like the problem before, we want to multiply to both sides. So we have 6 over 1 again, and 6 over 1. And in this case, we're taking that term and we're multiplying it by every term inside. This is why I like the arrows, because when there becomes more than 2 or more terms on each side, it can get a little confusing and you don't want to forget anybody. Again, important step to actually distribute it out so you can see everything. Once you go about seeing everybody with the distributive property, then you want to cancel out and simplify. 3 into 3 once, 3 into 2, there you go, 2 and 2 once, 2 into 6 3 times, 6 into 6 once each, good, and then 1 and then 6, so you could just left that one. Okay, and then you want to go ahead and simplify everybody again. So using your parentheses, 2 times 2x plus 3 times x equals 5 plus 6 times 2x. Then it's that famous question time again. Yep. What's happening to the variable? I don't know. You tell me. It's unknown. But in this case, it actually is known. So we want to go ahead and combine our like terms before we start isolating for one positive variable. So with this case, we have our 4x plus 3x equals 5 plus 12x. Get your like terms together, and we have 7x, and then we need to subtract, we want to get all of our variables on the same side. So this is where my famous song comes into play here. To the left, every single variable to the left of the equal sign. And it actually gets sung like this. Let me know if you can see where it's from. To the left, every single variable to the left of the equal sign. Yep, that's it. It's kind of nerdy and weird, but it's a little jingle that'll hopefully stick in your head. To remind you, by convention, we want to keep all of our variables on the left of the equal sign. So in this case, we need to subtract 12x, not just 12. So you subtract 12x from both sides, subtract 12x from both sides, and there you have a negative number, negative 5x. Do I want a negative variable as my solution? No, I want one positive variable. So what's happening to the variable? It's being multiplied by negative 5. What is the inverse of multiplying by negative 5? Yep, dividing by negative 5. What you do to one side, you must do to the other, so then you get x equals negative 1. You can box your final answer and plug that in with the calculator when playing with decimals and fractions to double check your work, and you are good to go. So hopefully those two examples shed a little bit more light on what you need to do. When playing with fractions, in order to isolate variables, you want to make sure you find your LCD first. After you find your LCD, go ahead and distribute accordingly to make sure both sides of the equations get that because of the law of quality. Cancel out and simplify, and then you just do reverse PEMDAS to figure out how to get your one positive variable. And check your answer with the calculator. And you're done. Okay? Okay. Also remember, if there are multiple terms, on both sides of the equation, then you need to combine them and get them all on the same side. So you need to apply the song, to the left, every single variable to the left of the equal sign, so that you can have all your variables together in order to find one positive variable. It's that time again. You try two. Two like two problems, and two like you try also. Okay, so you try number 1 is 1/4 x plus 2 equals 3/4 x. So this one's kind of easy because they're fourths. So we can clear out the fourths and then deal accordingly. What about the next one? You try number 2 is 1/2 plus x over 10 equals 2/5. In that case, where is your LCD? Yeah, your LCD is 10. So you try number 1, you're going to multiply by 4 on both sides. You try number 2, we're going to multiply by 10. Go ahead and try it, and then check your solutions. All right, you can do it. Okay, I'm going to pause right here, and notice if the fraction can be simplified without clearing, then you might want to save yourself some time, because as I'm looking at this, since they already have the same denominator, I'm actually going to move it to the right, even though the song says to move it to the left, but we know that you can rearrange things on both sides, so we'll move that around later. But I'm gonna do it like this because it'll hopefully save me some time here. So we have 2 equals, now we have 3/4 x minus 1/4 x. And that's just going to be 2 equals 2/4 x, which is a much nicer number there. And we don't have to multiply by everybody. So now that's 1/2 x. So basically here we just need to do what? what's the inverse operation of dividing by 2 on both sides, because that we know is really just 2 equals x over 2. The inverse operation of dividing by 2 on both sides is multiplying by 2 on both sides. Oops, that's a 1. Oops. Where is it going? There you go. Okay, so we're going to multiply by 2 on both sides. There are 2 cancels when the numerator equals the denominator. That is a unity fraction. So then you have, 2 times 2 is x, or x equals 4. Yay. Plug that back in there. With substitution, you can just eyeball that really quick and plug it in with your calculator as needed. But here we have 4 times 4 is 1, and 1 plus 2 is 3. And if I plug in 4 on this side right here too, the 4's will cancel, and I have 3. So does 3 equal 3? Yep. So we're good to go on that one. Check. Now, the next problem over here, we will have to distribute our LCD to both sides. So let's go ahead and do that. So we have 10 over 1 times the quantity 1/2 plus 10 over 1 times the quantity x over 10 equals 2/5 times 10 over 1. Alright, I'm going to just go through and do it, and you can check with your answer. There we go. Hopefully you got those same answers there. And again, 1/2 to check it would be another way of writing that. If we make everybody 10, it would be 5/10, and then plus -1/10 equals 2/5. And how can I rewrite 2/5 as a tenth? Would be 4/10. Good. So 5. Oopsies, you can't really see that. That should be a -1. And you plug that in. Good, so 5 minus 4, or 5 minus 1 is 10. Oh my gosh, 5 minus 1 is 4. And so you have 4/10 equals 4/10. Or you can simplify to 2/5 equals 2/5. And you still get the same answer. So you could check it by sight, or you can plug that into your calculator when we're playing with fractions and decimals. But hopefully that makes sense a little bit more on how to clear with fractions, or how to clear fractions when solving equations. You just want to find your LCD, distribute, and then play with it like normal. Alright, if you have any questions, go ahead and shoot me an email, text me, let me know. Bye!